Anyone who has ever seen a children's book about prehistory or visited a fossil museum probably knows the name Stegosaurus. This peculiar creature with huge plates on its back and four-pointed spines on its tail has become an iconic symbol of Mesozoic fauna. Its silhouette is so distinctive that people often think of it earlier than any other dinosaur from the Jurassic period. Although literally the whole world knows him, few people know how many secrets are hidden behind his strange appearance. Stegosaurus is not just a hulk with a small brain and a prickly tail. Its body has been perfectly adapted to life in the changing world of the late Jurassic. And as recent research has shown, it may even have played a key role in our understanding of the evolution of defense mechanisms, social behavior, and even the evolution of dinosaurs themselves. Get ready to travel back in time. To the time when the most interesting life forms the Earth has ever known walk the North American continent. We will explore every part of the Stegosaurus's body, its habitat, its enemies, and relatives. We will reveal how this armored creature defended itself against predators, what its daily life looked like, and how it became one of the most famous dinosaurs of all time. Immerse yourself in the fascinating world of a Stegosaurus that has so much more to it than you'd expect. At first glance, the body of a Stegosaurus looks strangely incongruous. A huge belly, an arched top line, and a very small head form a body structure that looks like a creation from another world. Stegosaurus was a four-legged herbivore with significantly shorter forelimbs than hind limbs. This resulted in its back sloping down towards its head, while the back of its body, including its tail, was raised. The skull itself was low to the ground, long and narrow, with small, flat teeth and a toothless beak that it used to tear off low-growing vegetation. This beak resembled a bird's or turtle's jaw, rather than a typical dinosaur mouth. In total, the Stegosaurus grew to a length of approximately 6.5 meters and weighed around 3.5 tons. Its neck was made up of 10 vertebrae. The following 17 hind vertebrae formed a massive spine that bore characteristic plates. The hind legs were strong and supported the heavy body, while the forelimbs were slimmer and shorter. On each hind leg, the Stegosaurus had 3 toes, while on its front legs it had 5 toes, some of which formed a kind of horn-like support. Scientific debates have been waged over Stegosaurus plates since the late 19th century. These flat formations were made up of osteoderms, bone structures located in the upper layer of the skin, similar to today's crocodiles. The plates were laid out in 2 rows, either symmetrically or alternately, depending on the species. The largest plates were located above the sides and reached a size of more than 60 centimeters in height and width. It is likely that they were covered in keratin, which would mean that their appearance alive could have been even more impressive than we know today from fossils. The function of the plates is not yet entirely clear. One of the most widespread theories claims that they were used for thermoregulation. They could help cool the body or, conversely, capture solar heat. This is supported by signs of vascular structures inside the platelets. Another theory suggests that it was a means of intimidating predators or attracting mates. If the plates were colored, for example red when perfused, they could create a strong visual signal. There is even speculation that the shapes or sizes of the plates differed between males and females, which would point to sexual dimorphism. The tail of a Stegosaurus was not just an ordinary part of the body, it was a potentially lethal tool. At its end there were 4 massive spines, which probably served as a defense against predators. Contrary to the idea of a slow, helpless herbivore, the Stegosaurus was able to lunge with this tail, with great force and precision. There is evidence that at least some of the specimens had their spikes damaged or healed from injuries, suggesting that he actually used them in combat. What's more, a vertebra of a carnivore Allosaurus was also found, which was literally pierced by a Stegosaurus tail spine. There is also the possibility that the spines could have been used in fights between males or for visual communication, similar to the antlers in today's deer. However, most scientists today consider the defensive function to be the main purpose of this promontory of evolution. The ability of stegosaurs to keep their tail off the ground and move it flexibly sideways suggests that it was a very effective mechanism against predators of the time. Stegosaurus has been shown to be found in what is now the western United States, especially in areas such as Colorado, Wyoming, and Montana. The fossil finds come mainly from a geological layer known as the Morrison Formation, which is one of the most important paleontological sites in the world. During the late Jurassic period, approximately 155 to 146 million years ago, this area represented a vast semi-desert landscape with marked seasonal changes. Dry seasons alternated with rainy seasons, when the landscape turned into vast swamps and floodplains. In this harsh and changeable landscape, the Stegosaurus was able to adapt enough to survive for more than 10 million years. The vegetation in the Morrison Formation was varied, from tall coniferous trees to ferns and horsetails, which formed a dense undergrowth. It was the low-growing vegetation that was the main source of food for the Stegosaurus, which could not reach higher than about 1 meter in height due to its body structure. While long-necked sauropods ate leaves from the treetops, Stegosaurus grazed vegetation near the ground, which led to a natural distribution of food niches. This ecological mechanism allowed many species of herbivores to coexist without direct food competition. The territory of Morrison's formation was teeming with life. Other herbivores roamed the landscape together with the Stegosaurus. For example, armored ankylosaurs such as Gargoyleosaurus or toothless ornithopods such as Camptosaurus and Dryosaurus. However, sauropods were the dominant herbivores here. Giants such as Brachiosaurus, Apatosaurus, Diplodocus, Barosaurus, and Camarasaurus formed the top of the plant-eating pyramid and completely dominated the landscape with their appearance. These dinosaurs were truly colossal, reaching lengths of over 20 meters and their necks reaching to the highest branches of trees. Although they shared the same environment, each of them inhabited a different ecological niche. Although the Stegosaurus looked impressive, it was not the largest or most dangerous inhabitant of its time. However, its success lay in how perfectly it was able to adapt, not only to vegetation, but also to the presence of other species. His armored body, low center of gravity, and natural respect he earned within the dinosaur community made him an unmistakable actor in this prehistoric ecosystem. One of the biggest predators that the Stegosaurus had to contend with was undoubtedly the Allosaurus. This carnivorous theropod was tall, fast, and had sharp teeth and strong jaws. In some depictions, he is compared to the lion of the late Jurassic, a beast that could attack weak, wounded, or young individuals. There is direct fossil evidence that clashes between the two dinosaurs did indeed occur. For example, the tail sting of a Stegosaurus was found embedded in an Allosaurus vertebra, evidence of the herbivore's deadly effectiveness of defenses. In addition to Allosaurus, other predators such as Torvosaurus, Martiosaurus, or smaller carnivores such as Ornitholesti could also target stegosaurs. Still, it seems that the well-armed and hardly vulnerable Stegosaurus was not easy prey. His spines and massive stature were a significant risk for attackers. Perhaps that is why most predators preferred to focus on other, less dangerous species. Stegosaurus was a member of the Stegosaurid family, a group of four-legged herbivores with characteristic plates and spines. This family developed as early as the Middle Jurassic and inhabited various parts of the world, including Europe, Africa, North America, and Asia. A common feature of all stegosaurids was small skulls, elongated bodies, and the presence of bony structures on the back or tail. In addition to the Stegosaurus, this group included, for example, Kentrosaurus, Huayangosaurus, Miragaia, Hesperosaurus, or Werhosaurus, its closest known relative, which lived in the early Cretaceous in what is now China. Although the Stegosaurus was neither the first nor the last representative of this group, it was he who gave it its name and became its most famous representative. Research on this family reveals how varied and diverse the evolution of armored dinosaurs was. While some species had spines instead of plates, others developed specific body shapes or a completely different way of defense. The Stegosaurus family tree thus provides us with a unique insight into the dynamics of dinosaur development during the Jurassic and Cretaceous periods. The first Stegosaurus fossils were discovered in 1876 in Colorado by paleontologist Marshall Parker Felch. The fossil fragments were then sent to renowned paleontologist Othniel Charles Marsh, who formally described the dinosaur a year later. Marsh originally thought it was an aquatic reptile similar to a giant turtle, interpreting the plates on its back as part of an armored carapace. It was from this idea that the name Stegosaurus came from, which translates as roof lizard. In the following years, other important finds were discovered. In 1879, paleontologist Arthur Lakes excavated parts of the skull, vertebrae, skeletons of limbs, plates, and tail spines. Finally, in the year 1885, an almost complete skeleton of a young individual was found. This discovery allowed paleontologists to reconstruct the overall appearance of a Stegosaurus for the first time and study its anatomy with unprecedented precision. It is thanks to these fossils that the Stegosaurus has gained a place in textbooks and museums around the world. The original reconstructions of the Stegosaurus seem almost laughable today. The first models depicted it as a ponderous reptile, with 8 spines sticking out into the sky, with its tail dragged along the ground, and plates stacked in a perfectly symmetrical line. This idea has persisted for several decades, and has taken root in the public consciousness. However, over the course of the 20th century, thanks to new findings and advances in anatomy and biomechanics, scientists gradually uncovered the true appearance and behavior of this dinosaur. Today we know that the Stegosaurus had its tail raised above the ground, the spines pointed to the sides, and the plates were distributed asymmetrically. Understanding the structure of its skeleton has led to new reconstructions that depict the Stegosaurus as a dynamic creature, strong, armored, but at the same time adapted to its specific lifestyle. The transition from myth to reality is a beautiful example of how paleontology as a science is constantly evolving and correcting its own mistakes. Of all the dinosaurs of the Jurassic period, the Stegosaurus is one of the most iconic. He has appeared in countless books, documentaries, films, and animations. From the classic 1933 King Kong to Disney's Fantasia to modern renditions in the Jurassic Park and Jurassic World series. Thanks to its characteristic appearance, it has become a fixture of children's books, plastic figurines, and museum exhibitions. His name is known even to those who are not very interested in dinosaurs. And this is what makes him a true cultural icon. But it's not just about its appearance. The Stegosaurus is also a symbol of the transformation that paleontology has undergone over the last century. It represents a dinosaur that we did not understand at first, but thanks to science we have discovered it again, this time in all its complexity and beauty. The Stegosaurus does not only live in fossils, it also lives in human fantasy, in films, in books, and in the memories of children who first encountered the prehistoric world. Stegosaurus belongs to the suborder of dinosaurs, specifically to the Stegosauridae family. It evolved from older members of the Theriophora group, which includes well-known armored dinosaurs such as Ankylosaurus. The basic feature of this entire developmental branch is the presence of bony structures in the skin, osteoderms, which in various species resulted either in dorsal plates or in armor. The first representatives of stegosaurids appeared in the Middle Jurassic and have since spread throughout the northern hemisphere. While the Stegosaurus is known mainly from North America, other members of this group inhabited the territory of today's China, Africa, and Europe. Its relatives, such as the Huayangosaurus, Miragaia, or Kentrosaurus, differed in body structure, plate shape, and body height. Kentrosaurus, for example, had spines rather than plates, while Miragaia had an extremely long neck. This diversity shows that armored herbivores were not an evolutionary dead end, but rather a very adaptable group with diverse ecological strategies. Stegosaurus lived during the late Jurassic period, approximately 155 to 145 million years ago. Its fossils have been found primarily in the Morrison Formation, a vast sedimentary area stretching from New Mexico to Montana. At that time, this area resembled a dry savanna with river floodplains, seasonal floods, and sharp transitions between the dry and rainy seasons. The plant world consisted of ferns, cycads, conifers, and horsetails, ideal food for the low-grazing Stegosaurus. Although the main occurrence is known from the territory of today's United States, relatives of the stegosaur lived all over the world, which proves how successful this evolutionary direction was. The youngest known member of this group, the Wuerhosaurus, occurred in the early Cretaceous, bridging the critical geological period between the two epochs. This means that armored herbivores have survived many changes in climate, flora evolution, and the emergence of new predator species, at least temporarily. Despite how famous and well-preserved the Stegosaurus is, there are still a number of unanswered questions. For example, we don't know exactly what his tablets looked like in life. Were they really colored? Did they have role models? Were they different in males and females? These are all questions that can only be answered by an exceptionally preserved fossil, such as those we know from China. For example, from the Yixian region, where feathery predators and colorfully reconstructed species have been discovered. Other questions are related to behavior. Did stegosaurs move in herds? How did the defense against predators go? Were they territorial? And what about their way of reproduction? Did they lay eggs in nests like today's reptiles? Or did they take care of their young like some birds? Each new discovery, whether in rocks or in old museum collections, can change what we think about this dinosaur. It is possible that one day we will know its true coloration, as with several feather-covered dinosaurs. Today, the Stegosaurus is more than just a long extinct creature. It is a symbol of our curiosity, desire to understand the distant past, and the ability to transform knowledge on the basis of new discoveries. This dinosaur shows how far we have come in understanding evolution and paleontology. From incomplete bones in the 19th century to detailed digital models and animations in the 21st century. His body, so strangely built, has aroused questions and fascination for generations, and this is what makes it an exceptional paleontological phenomenon. At the same time, the Stegosaurus also serves as a teaching tool. It teaches children how scientific knowledge evolves and reminds them that what we know today may not be true tomorrow. It has become a legend in culture. Its silhouette is part of logos, museums, documents, textbook covers, and TV series. And although he has long since died, his presence in the world of people is still strong. Perhaps this is how the Stegosaurus achieved immortality, not in fossils, but in our collective memory. Although it is generally known by only one name, the Stegosaurus was not just one species. Currently, 3 are mainly recognized: Stegosaurus stenops, Stegosaurus ungulatus, and the lesser-known Stegosaurus sulcatus. Each of them had a slightly different body structure, number, and distribution of plates, and even different proportions of the skull or tail. Stegosaurus stenops was probably the best studied because we have its complete skeleton. It measured about 6.5 meters and weighed about 3.5 tons. While the stenops had plates distributed alternately on both sides of the back, in other species they could be arranged symmetrically or differed in shape. For example, in ungulatus, the plates were larger and more vertically oriented, while in sulcatus, they could have sharper edges and a more pronounced keratin cover. These differences could have served both for species differentiation and for sexual selection or territorial designation, similar to the antlers of deer or the manes of lions today. Stegosaurus often appears on lists of dinosaurs with the smallest brains relative to body weight. Its brain weighed about 80 grams, which is really very small for a creature weighing over 3 tons. This fact became a laughingstock in the 19th century and led to the idea that the Stegosaurus was an extremely stupid, almost soulless creature. Some speculations at the time even claimed that he had a second brain in the pelvic area, which we now know is a mistake. It was just an enlarged nerve canal. Nevertheless, caution is required when assessing the intelligence of extinct animals. Brain size does not necessarily indicate behavior or cognitive abilities. The Stegosaurus apparently had a simple brain adapted to its lifestyle. It needed to evaluate stimuli from the environment, coordinate its massive body, protect itself, eat, and reproduce. Within its ecological niche, it was completely sufficient. They were not thinkers, but survivors, and that in itself is proof of success. The Stegosaurus plates are not just an iconic decoration. According to scientists, they can also serve as identification marks of individual species or even individuals. As with zebra stripes or human fingerprints, it seems that no two plates were exactly alike. Shape, size, distribution, and slight curvature differed not only between species, but also within one individual. This has led some scientists to believe that the tablets may have been a visual mark of sorts, a kind of prehistoric citizen. Theoretically, these structures can also be used to determine the age of the individual, according to growth lines, health condition, such as injury, infection, or deformation, or even dominance, if they were larger or more brightly colored. Thus, the plates could have served as courtship signals, as a means of intimidating an opponent, or as a warning visual code to predators. If we ever discover exceptionally well-preserved specimens with keratin surface, we may be able to determine their original color, and thus open the door to other secrets of prehistory. The Stegosaurus stayed on the scene of Mesozoic life for a surprisingly long time. It appeared in the late Jurassic period, approximately 155 million years ago, and its traces disappear from the fossil record 10 million years later. Thus, it was not a sudden extinction caused by a catastrophe, but rather a slow decline due to ecological changes. With the onset of the Cretaceous, the climate and ecosystems changed. The composition of plants changed, new predators and food competitors appeared. Many species, including the Stegosaurus, were unable to respond quickly enough to these changes. Its relatives in other parts of the world survived for some time, for example, the Werchosaurus in China. Nevertheless, at some point, the evolution of armored herbivores shifted towards ankylosaurs, whose bodies were more massively armored and whose ecology was better suited to the new conditions. While the Stegosaurus quietly disappeared, its fossil footprints and cultural legacy endured, becoming a bridge between the ancient world and human curiosity. It may not have become extinct dramatically, but certainly not without a trace. The Stegosaurus is more than just a well-known dinosaur from books and museums. It is a symbol of transformation, both in nature and in science. The creature that we once attributed a turtle shell and 8 spines to an armored herbivore with fascinating abilities and unexpected evolutionary equipment. Its plates, tail, and unusual body structure carry much more than we ever thought. The story of a Stegosaurus is not just about its life in the Jurassic, it is also about us, about how we learn, change our minds, and move on. If you want to discover other similarly incredible dinosaur stories, don't forget to subscribe and support other prehistoric adventures. Thanks a lot!